Good morning, everybody. Welcome to Exciting Morning on Chem 1105 with your host, me, Dr. White. Hi, everybody. I hope you had a nice time since we last met. All right, couple things. First of all, on a personal note, I've noticed from YouTube, either all of you are watching my videos a lot of times, or there's some people who are not in my class. If you're not in my class, could you please leave in the comments section of YouTube what school you're from or where you're from? I'm just nosy. See, I'm nosy. Oh, it's Awful Humor Monday. All right. Now, let me remind you, this Wednesday after class, I will send out an email with the password for the password protected PDF file for test number 1, which you will be able to download starting sometime, probably tomorrow afternoon from the assignment area of Blackboard. You'll have from the time you get the email until I think 1 p.m. Thursday to test number 1 and turn it into PDF file and upload it. If you do not have a printer, you can write out the answers on a piece of paper, scan it. If you don't have a scanner, use your cell phone and convert it into a PDF file. I have files how to do that. It'll be there with that. Whatever, this is thirsty work this morning. And that's what you'll do. Excuse me. And you'll have, like I said, about 24 hours to take it. You know, I could say, take only 1 hour to do it. Nah, take a couple hours to finish. I'm not going to be able to time you. And if we were face to face and I give 55 minutes, then I have to be out of the room I'd be in at COD. But most students, if you've done the practice problems, most students are done my hourly exams in about 35, 40 minutes. I don't write an exam, so only the best can barely finish. That's wrong. Now, you will need a calculator. I have this the one I talk about in my syllabus. You go back a couple of videos, I went through how to use that with scientific notation, which you will need to know. Under your name, it will say, please use proper significant figures for all calculated answers. So you know how to do significant figures? We've gone through multiplication division. You get the lowest, the number, and then let me start again. Your answer should have the same number of significant figures as the number you're multiplying or dividing that has the lowest significant figures. And your calculator, as you saw in Appendix A2, A4 answers, problem set answers, will give you a ton of significant figures, and you have to round that off, which I taught you. Every question on test 1, I've gone through the concept of that question in the lectures at least twice, a lot more than twice. All right. Now, I will also provide for you to download a PDF periodic table, this one. We've used it all semester, so you should know how to use that. Next, give me a second. I forgot I have to open up something. Maybe more than a second. All right, you should see on your screen Blackboard for this course and course information. If you click on the lectures folder, if you scroll down near the bottom, you'll see important information, test number 1. This will be the last page of the test you will get on Wednesday in the PDF file. And this information hold on 1 second. This information you don't have to memorize, but you will have to memorize, like for the electronic shells and the number of shells. And I'm going to change this, I'll try and remember the maximum number of electrons. And going from the top to the bottom, the energy increases in both the first table, electronic shells, and the second table, number of electrons in each subshell. Everything else you have to memorize, like what's a homogeneous, what's a heterogeneous solution. And you'll see in test 2, this will be even longer. But you can go to the assignment area and see that. Now, if you also scroll down in the lecture section of our course, you'll see I have a file, test 1 review. I will go through this tomorrow, and you can go back and look at the video and also download this to help you study for test number 1. And that's important information about test number 1. And if you have any questions, come by my office hour Tuesday or Wednesday. If you have questions during the test, either come to my office hour or email me. On Wednesday afternoon and evening, I will check my email every 2 hours, and it's also part of Thursday morning. I do have a dentist appointment, ouch. But anyways, so I'll be able to check until 9, and then when I get back about 11. And that's test number 1. Does anybody have any questions? All right, now let's talk about the labs. The labs, later today or tomorrow, the safety lab, I grade it. And with anything I grade, if you have a question, why did I get this score on a test or on a lab, always feel free to see me after a lecture, see me during my office hours, or email me, or we can set up a private Zoom meeting. Because in my class, there's no such thing as a dumb question. And I think I'm fighting a cold or something. But anyways, always feel free to ask anything. That's including why you got the score or grade on anything. Now, speaking about test 1, you'll have until Thursday, 1 p.m. I think they take it and upload it as a single PDF file. I will grade them. Since we're not going to see each other face to face, how do I get it back to you, what you did? All right, 1, in Blackboard, I will post by Sunday, 1 p.m. after the test, probably earlier, but at the latest, your scores for test number 1 in Blackboard, and I'll send out an email and post an announcement. Also, by Sunday, 1 p.m. or earlier, probably earlier, I will send each of you an individual email, and in that email will show you the points you got for each answer you have on test number 1. Oh, that reminds me, I'll do this in a second. And a week from today, Monday, I will go through all the questions with answers for test number 1. Now, cut it out of the video I put on YouTube that's public, but I'll turn the part that I cut. I like my special effects. I'll create a separate YouTube video that will be private, that will have that part going over the answers in case you can't make it to our Zoom meeting. And I'll send out the URL for that to each of you in an email. Now, I don't know if I covered this. When did I do this? Yeah, I think I did last Wednesday, but just a reminder, on Wednesday, I'll be giving test 1, and you'll have until Thursday, 1 p.m. I have here take 2 hours. If you need 3, that's okay. You shouldn't, but if you do, test 1 will cover chapters 1, 2, and 3, along with appendix A2 and A4, which I've covered. And when we're done just now with these announcements, I'll go over the practice problem answers for chapter 3. And here, test 1 has 29 problems. Relax, seems like a lot, but you'll have plenty of time to do them. They'll have 7 multiple choice. It has 8 pages, including the formulas I talked about. You'll need a periodic table, which I will provide. And this is important. I reserve the right to subtract up to 25 points for anybody who doesn't follow instructions, meaning upload it as a single PDF file or get it uploaded on time. And the rest I've already talked about. All right, any questions about test number 1? All right, let me make this a little smaller. All right, let's go through practice problems, chapter 3. Oh, on a special note, you will understand why I call these practice problems after you take test number 1. I like special effects. I'm ambidextrous, I'm stereo. But you will know why after test number 1, I call these practice problems. Hence, all right, let's go through them. You should know, what are the 3 subatomic particles of an atom? And those are the electrons, the protons, and the neutrons. What charge is on a proton? Positive. What charge is on an electron? Negative. All right, next, how many electrons and protons do each of the following elements have? And how do you know for carbon? First of all, you need to know its chemical symbol C. Then, if you go to the periodic table, here's carbon. The atomic number equals the number of electrons equals the number of protons. This number for that, the atomic number, not this. And therefore, it's 6. Oh, I got it right. If we go down to mercury, a chemical symbol Hg, again, how many electrons, how many protons? Right here is mercury, and it has atomic number of 80, which means 80 electrons, 80 protons. Oh, I got that one right. And the same are true for the other answers. Look at the periodic table, find the atomic number, and then that's the number of electrons and protons. Now, write the electron configuration for nitrogen. And if you look at important information, test number 1, it has numbers, letters, and superscripts, I think. So how do you do this? Well, first of all, you have to find for nitrogen how many electrons, and you have 7. Next, I think I closed it. Oh, hold on. Next, in case you forgot, well, I have hint numbers and letters only. And statement, how many electrons an atom has in each of its subshells. Remember, a subshell is identified by a number, the shell, and a letter, and then the number of electrons. And you always start from the lowest energy shell. And same thing with the subshells. You fill the lowest energy. To the highest energy. Always start at the lowest energy. So the first shell, lowest energy is 1, has 1 subshell, and that is 1s. And I can only put 2 electrons in there. So if we look at this, well, I put my 2 electrons in 1s. It's full, because you can only put 2 electrons in any s orbital. Well, 1 only has 1 subshell, and I filled it. So now I go to the next shell, lowest energy, I filled 1. Now I'll go to 2. And 2 has 2 subshells, 2s and 2p. 2s, it's an s subshell. I can only put 2 electrons. And I did. Well, now 2s is full. 2 has 2 subshells. Remember, a subshell is identified as a number, the shell number plus the subshell letter. And now, since I filled 2s, I now go to 2p. And if you look at 2p, any p orbital, I can put in 6 electrons maximum. But I have 2 plus 2 is 4. I need to get 7 electrons, and therefore I only need 3 more. So I'll put them in 2p. I could have put up to 6, but I don't have to. Let's do one more. Let's do the electron configuration. Do the one for sodium. So first of all, sodium has a chemical symbol, which you don't have to write down, but you have to know, Na. How many electrons does sodium have? We look at our periodic table, sodium, which is an alkali metal. You should know the first column other than hydrogen are alkali metals. Second column, really magnesium, calcium, alkaline earth metals. All the way on the right, second to last column, fluorine, chlorine, bromine, iodine, halogens. And the last column with the 8 above it is the noble gases. But back to sodium, we need to know how many electrons does sodium have? Well, it's got an atomic number of 11. The atomic number tells you how many electrons, how many protons. And that was 11. So I have 11 electrons. The first shell is 1, the lowest energy subshell from the table, 1s. The maximum number of electrons I can put in is 2. 1 has 1 subshell. I filled it up. Now I go to next lowest energy, which is 2. The first subshell in 2 is 2s. Any s orbital, not orbital, subshell, I can only put 2 in. Well, I filled it up. I got to go to 11. I've only done 4. I got a lot more to go. Now, 2 has 2 subshells, and the second one is P. The maximum number of electrons I can put in there is 6. It's on that table that you'll be given. So I now count for 2 plus 2 plus 6. 10 electrons. I'm not done yet. Now, shell 2 has 2 subshells, S and P. I filled it out. So I have to go to next shell 3. And the lowest energy subshell in 3 is 3s. And I have 10 electrons counted for, 11 minus 10. That's the number of electrons I need to do is 1. And that's it. 1s2, 2s2, 2p6, 3s1. Now, don't forget, don't tell anybody I'm being nice, about my special gift that I will do for test 1. What's that gift? For the electron configuration, you have to know how to do the elements 1 through 12. Again, those are the only ones I'll do, 1 through 12. Any of those you should know how to do. When you get the higher atomic numbers or the elements, some of the rules break down. You got to learn the exceptions. Not worth it. Trust me. Unless you're going into that area of chemistry, ain't worth it. All right, let's continue on. How many valence electrons do the following elements have? Now, first of all, I don't have it here. But you should know what is a valence electron. And the valence electrons are the outermost electrons of an atom. I'll be subtle. Is that being subtle? I should make that electrons. You should know what is a valence electron. It's the outermost electrons of an atom. I'll say that again. Hint, you should know what is a valence electron. It's the outermost electrons of an atom. Now, how do you find a valence electrons? Well, how many valence electrons does hydrogen have? You should know hydrogen, chemical symbol H. And if you look at the periodic table, you will use as both Roman and red numeric numbers, and the number is 1. The numbers on the top of the column, called families, tells you how many valence electrons. Therefore, hydrogen, not the atomic number, but the number on top has 1. Now, once you know the valence electrons for one element in a column, you know them all. And here, lithium has 1 valence electron, sodium, potassium, and the rest do also. You don't, for valence electrons, look at the atomic number. No, you look at the top. Now, oh, my favorite, carbon. And carbon, the chemical symbol is C. And you look at the top of the column, and the number is IV, which is Roman numeral for 4. I give that to you. And therefore, carbon has 4 valence electrons. I'll let you try one. How many valence electrons does oxygen have? Your turn. All right, oxygen, chemical symbol O. You look at the top, not at the atomic number for valence electrons, and that is 6. So oxygen has 6 valence electrons. Oh, this is fun. Let's do another one. How many valence electrons does argon have? Your turn. Push my clock with the second hands. All right, argon has a chemical symbol AR. And it's in the last column, it's a noble gas. And you look at the top, you see VIII, which is the Roman number for 8. And argon has 8 valence electrons. And you should know how to do that. And here I have a couple other, and that's how you do it. And we're done with Chapter 3, question, practice problem questions. Again, if you can do the practice problems for Chapter 1, 2, 3, plus Appendix A2 and A4, you'll do really good on test number 1, which I hope you all do. But you got to practice. You just can't watch me on my video and say, oh, that's not that hard. No, you've got to do it alone without looking at the answers. And then you can look at the answers and go back and watch the video. Any question about Chapter 3? Oh, just to remind you, remember a subshell is designated by a number and a letter. A subshell is designated by a number and a letter. I'm saying that because on test number 1, I see students just put letters down. Wrong. Ooh, new symbol. Wrong. That's me writing an X through that. If I were writing on this, your tests, I don't. I have a spreadsheet where I keep points when I grade it. All right, that's everything for test number 1. Let's go back to Chapter 4, Part 1. This will be on test number 2, coming up in the future.
Dr. White.
I hear a question. Let me get back here.
Sorry,
Go
just because I walked away from my computer for
Yeah.
a second.
Go for it.
Did you say that going forward now is the stuff for the material for like next exam?
Yes, I did.
Okay, and when are your office hours?
Would you what?
When are your office hours?
My office hours are on Tuesday from 6 to 7:15 and Wednesday from 6 to 7:15. The Zoom login, which is different than the lecture, is in my syllabus. There's also on Blackboard for this class. Hold on. Do you see on your screen right now, Katie?
Yeah.
Zoom meeting, and then if you scroll down, here's the link to the office hours. And this is the wrong. This should be from 6. I got a mistake. That should be from 6 to 7:15. I'll have to go back and correct it. Hopefully it's correct in my syllabus. No wonder people haven't been showing up. No, actually, I just, for whatever reason. But I have it correctly in my syllabus. I'll have to change that in Blackboard. All right. Now,
Okay.
if you can't make it, let me know. And if I'm available, we can set up a private Zoom meeting. I'll do that for any student before a test for any time.
Okay, great. I think I'll shoot you an email then sometime
All
today.
right. Remember, I read my emails twice a day, every day, early in the morning. I mean, early. Like this morning, I think I read my emails about 6:15 or so a.m. And then later this afternoon or this evening, I'll do it again.
Okay, thanks so much.
You're welcome. All right, any other questions? Now, last week, I ended up writing ionic formulas. Remember, this is test tube material for ionic charges. And remember, all molecules have a net zero charge. All molecules, and you should know this, again, this is test tube material, have a net zero charge. Now, question is, write the formula, or I could also write empirical formula. That's a P formula for a molecule with the following ions. Now, sodium has a +1, and chlorine has a -1. That's what this tells you. And that means it has to add up to 0. It does. Since we cannot change the charge, you can always change how many, but in this case, one of each adds up to 0. So sodium chloride, table salt, the answer would be this. If you ever go out to breakfast, lunch, or dinner with a bunch of chemists, and I have to admit, I've been guilty of this, and somebody wants the salt when you're at a restaurant, could you please pass the nickel? Now, let's look at B. And that is write the formula, empirical formula for a molecule with calcium +2 plus bromine, called bromide ion, anion -1. All molecules have a net zero charge. This doesn't add up to 0. So how do I do that? I cannot change the charge. Students want to do that, and you can't. It's wrong. But I can change how many. If this is a +2, this has to be a -2. So if I have 2 of them, it's now adding up to 0. So what this tells me is I have 1 calcium, when there's no number thing, 1, and I have to bromine. Your turn. What would be the formula for a molecule with sodium cations and fluorine anions? And when you're done, if you can, give me the emoji of thumbs up. All right. Maybe another 20 seconds. All right. This is a +1. This is a -1. It has to equal 0, and it does. And that's the formula for this. This is called sodium fluoride. I always spell fluoride wrong, but maybe I did it right this time. Now, where do you find sodium fluoride? In your toothpaste. You use toothpaste, to clean your teeth. If you look on the ingredients label, and let's do that right now. If you look, oh, Crest, not that I'm telling you should get Crest, but the active ingredient is sodium fluoride. And that's an anti-cavity additive or ingredient to help promote good teeth. I think about 1935, give or take a few years, dentists found that this one town in Texas, nobody had almost 0 cavities. They had a phenomenally good teeth and no dental problems. What's going on here? And they investigated, and the only thing they found different from the rest of the United States was the water they used had a high sodium fluoride level. And they concluded that helps promote good dental health. And that's been put in our water supply, at least in Chicagoland, and also in our toothpaste, most brands. Let's do one more. And here we have magnesium +2 and so iodine -1. What would be the empirical formula for a molecule containing those ions. Your turn. All right, let's do this. Magnesium has a +2 charge. How do you know that? Right there. Iodine, if you look right there, has a -1 charge. All molecules have a net 0 charge. Well, this doesn't add up to 0. You cannot change this, but you can change how many. This is +2. This whole has to be -2. If I put a 2 there, 2 times -1 is -2. So now adds up to 0. And this molecule, magnesium iodide, has 1 magnesium. And this 2 tells me in subscript to the right 2 iodide. One thing I should write down, as students do, is this. No, that's not the way you do an empirical formula. The number of ions is always to the right of the chemical symbol and subscript, not up here, subscript right there. If I look at the clock, it's time to take a 5-minute break. So I'm going to take a 5-minute break and get up and stretch a little, and then we'll continue. See you in 5. All right. Welcome back. And let's continue. We're talking about the empirical formula of polyatomic ions and how to draw that structure, not structure, the empirical formula. Now, in chemistry, if you have an ionic compound with two elements, you can name them. Switch is off for this slide. How do you do that? The metal ion is the name as the name of the element, followed by the name of the nonmetal ion. And subscripts are never mentioned. Again, switches off. How do you call that? This is sodium. Now, for the non-metal ion, the halogens are called, you drop, say this is fluoride, fluorine, drop the INE ending and convert it to IgE. This would be sodium fluoride. And similarly, even though there are two here, by the way, this is calcium. This is a chlorine, so that becomes chloride. And this is the white pellets, calcium chloride, you buy from the home improvement store or other places too, that you throw in your driveway. I like my special effects, or your sidewalk when it's super cold. We've been lucky this winter when there's a lot of ice on it and it melts it. I'll teach you later on why that happens. So this is how you name them. And I've already done writing the formula, and click, switch would be off. This won't be on a test or final mark. And metals that form more than one positive ion, same as previous, except metals with more than one possible ion, a Roman numeral, sometimes the old way, has been added, like calcium, II chloride. That's not right. But anyways, that's that. Now again, this will be off, click. How do you write the formula from the name of ionic compound? The first part describes the metal, and the second part describes the non-metal. And you've got to figure out how to add the number so you have a net zero charge. Again, this slide, click, switches off. It will not be on a test. Click, switches on. Back, I'm going to be subtle. And know this. Let's talk about polyatomic ions. I won't ask you to know the definition, but I will ask you to understand how to use them. And let's go through that. First of all, what is a polyatomic ion? It's a group of atoms that have acquired electrical charge, which is shared among the atoms of a group. Again, it's a group of atoms that acquire an electrical charge, a minus charge or a plus charge, and that's shared among the group that exists together of these atoms. Now, if you look at the name polyatomic, well, you know, atomic means atoms. The word prefix poly in chemistry means many. Poly means many. Ooh, quick Dr. White story. I teach at Elgin Community College many years ago. I was introduced to a mutual friend of ours, Polly Nash. Unfortunately, about a year and a half ago, Polly passed away. She was at that time Dean of English at Elgin Community College, which I also taught. And through this mutual friend, I got to know Polly. But the first time I met Polly at this mutual friend's party, oh, Polly, do you know your name means many in chemistry and Greek? And she gave me that look like, hey, you know how many million times I've heard that? She didn't say that, but I got that from her look, and I apologize. Great lady. Quick story. A group of us from ECC, Elgin Community College, instructors and dean too, when the first Harry Potter movie came out, we said, let's go together and see that. That was Harry Potter and the Philosopher's Stone or something stone. But anyways, we went to the movie theater. A number of the kids were dressed up in costumes, and so was Polly. She actually went out there selling replicas of the Nimbus 2000 broom. It was quite cute. Never grow up. Always let the little kid inside you exist. All right, let's look at polyatomic ions. You name them. I'm not going to expect you to know this. Click, switches off. Names of the most common polyatomic anions end in ATE. Now, I'm going to ask you to learn some of the names of the polyatomic ions on the next slide. Click, switches on. Now, for now, you should know nitrate is NO3 minus, nitrite NO2 minus, bicarbonate is HCO3 minus, and later on, way down the semester, you'll learn about hydronium ion and hydroxide ion. Now let's talk about a couple of these. Nitrate and nitrite. Now let's look at the following. Hang in there, I'm almost done. So the question is, give the empirical formula for a molecule with the following ions, 3 points each, sodium plus and nitrate, NO2 minus. Well, this is a +1, and this whole thing, NO2, has a -1 charge. All molecules have a net 0 charge. Well, guess what? This adds up to 0 So that means there's one sodium when there's no number in front of charge 1 and one nitrate. How do you write that? One sodium and one nitrate. Now, sodium nitrate for many, many generations Now, if you look, and let me make sure you can see it, and you can, for many generations, processed or cured meats have a preservative in there called curing salts, sometimes called pink salts. And one name or type is frog powder 1, which is sodium nitrite and table salt. And that's what we just said, NO2. And somehow that inhibits bad things happening like bacteria happening in the curing. Now, there's another one that has both a mixture of sodium nitrite and sodium nitrate, which is NaNO3, one sodium plus, one NO3 minus. And this also has been used in there. Now, one of the most popular, I think that's the right word, cured meats is bacon. I don't know about you, but I like bacon. And not that I need it, but I like it. And bacon is cured. What does it say here? No, it doesn't say it right. Bacon has sodium nitrite in it, and I think also some sodium nitrate. And bacon is one of the cured meats, salami too, has a high level of sodium nitrite in there. Now, some people say that has negative effects in your body. I don't know, I've been eating it. I'm still alive, thank God, but it might. But that's a polyatomic ion used in a molecule. Now, let's look at carbon, sodium bicarbonate. Oh, I got ahead of myself. Bicarbonate is HCO3 minus, called the bicarbonate. Remember, these are ionic compounds. The opposite charges attract. Got ahead of myself or out of sync. And the question is, what would be the empirical formula for a molecule with sodium cations and bicarbonate anions? Your turn. Remember, all molecules have a net zero charge. And remember, I give everybody time to finish. All right, let's get going. How do you draw this? How do you determine the empirical formula? This is a +1 charge. This is a -1 charge. All molecules, the net charge have a net zero charge. And +1 -1 is 0. This tells me there's 1 sodium and 1 bicarbonate anion in this molecule. It's called sodium bicarbonate. And you know that as baking powder. Sodium bicarbonate is essentially baking powder. And if you look on the screen, you'll see one brand that's made in, let me check to make sure you're seeing this. And you are, is the weird name, at least weird to me, Gabler Girl or Clabler Girl. And this is found in some of the stores here in Chicagoland area. And that's made in northern Indiana. I don't see here, let's see if I can find it. And another very popular brand is Calmet. That's the one my mother used and I use, or once in a while, I'll buy a store brand. But think about it. This material is a chemical and it contains sodium bicarbonate. Now, this is important and watch closely. I can write it correctly. And the question is, draw the empirical formula for the molecule containing magnesium +2 cations and sodium -1 anions. Well, this is a +2. This is a -1. It has to equal 0. It doesn't. You can't change the charge. So this has to be a -2. Well, if I multiply 2 times -1, this is now true. So this tells me I have 1 magnesium because there's only 1. Now, how do I show 2 of these polyatomic ions? nitrate, NO2. I put it in a bracket. Bracket, the ion, polyatomic, NO2, close bracket, and then subscript to the right. I need two of them. So that's how you do this formula. Let me do that again. We have a +2 and a -1. We see it there. And now, how do you draw this or write the formula? I have 1 magnesium, but I need 2 of these. I put it in my bracket and then subscript. I put 2 because I need 2 of them. The following is wrong. This is wrong. And also students do this. Oh, I need 2 of these, so I'll do this. 1 nitrogen times 2 is 2 and 2. 2 oxygen times 2 is 4. This is wrong. You put the polyatomic ion in brackets, and then to the right of the closing bracket subscript, you put the number. This is thirsty work. Your turn. Write the empirical formula. A molecule with calcium plus 2 cations and the bicarbonate HCO3 minus polyatomic anion. Your turn. Write the empirical formula. Remember, I give everybody time to finish. All right, let's get going. How do you do this? This is a +2, the calcium charge. We learned right there. Now the bicarbonate has a -1 charge. All molecules have a net 0 charge. Guess what? It does that up to 0. This is a +2. This is a -1. Well, you can't change this number. Nuh-uh-uh. I heard that. But you can change how many to get to 0. This is a +2. How do I make this a -2? put a 2 there. Well, what does this tell me? There's 1 calcium cation. And then, since I need 2 of these, I'm going to put it in a bracket, close the bracket, and since I need 2 of them, subscript to the right of the bracket they use to close, I'll put a 2. And this is calcium bicarbonate. And that's how you do it. Now, if we look at hydronium ion, we'll find that's a very important polyatomic ion. So is hydroxide. Oh, let's do one more. And there you go. What would be the empirical formula of a molecule with sodium plus cations and OH, which is hydroxide minus 1 anion? Your turn. Remember, you're trying to find out what's the empirical formula for a molecule with sodium plus hydroxide minus ions. All right, my turn. This is a +1. And the hydroxide is a -1. All molecules have a net 0 charge, and this adds up to 0. So that tells me I have 1 sodium and 1 hydroxide. And we have NaOH. This is called sodium hydroxide. Remember, OH minus is the hydroxide ion. Now, this is called, and I'll teach you later what I'm about to say, the IUPAC, or official name. Now, it also has a common name. And that is Li. And Li has been used for many centuries by many people for many things. And here, Li is sodium hydroxide. Now, here's what it looks like as potassium. Here's sodium Li, which is mainly what I think of. Now, I'll teach you later in the semester, but how many of you have ever heard of lye soap? Well, if you take animal fat and boil it up with water and with lye, there's a chemical reaction and it separates the fat, or you could also use vegetable oil, that into compounds we call sodium carboxylate anions. I'll teach you about that later on in the semester, and glycerin. And use the sodium carboxylate anions come to the surface of that boiling water and lye. And when it cools down, you got a white solid that you can scrape off the top of the vessel you did that. In the old days, like in the 17 and 16 or earlier hundreds, that was in a big metal pot over a fire. And what they were making was lye soap. And I worked for a company, we did it a different way, but we made those same chemicals from fats and oils, mainly fats, like beef fat and pig's fat, to the tune of millions of pounds a week. Yes, millions of pounds a week. And I'll tell you that story later on. All right, we talked about writing formulas from compounds containing polyatomic ions. All molecules have a net zero charge. We just went through that. And the same rules for balancing that. If I look at the lower right, left-hand corner of our slide, I see we're on page 27 of 27. And you know what that means? We're done with part 1 of chapter 4. It's time for a new part of chapter 4. Wrong way. It's time for chapter 4, part 2. Remember, this will be on test number 2, not test number 1, which I'll be giving on Wednesday after class. Now, on your screen, and let me check to make sure that's what you're seeing. And you are. Chapter 4, Chemical Bonds, Part 2. Remember, there are 2 types of chemical bonds. Ionic, which I just showed you, the compounds we just did with ions are held together by ionic bonds. Now, the other type of chemical bond is the covalent bond. Now, on this chart table, the screen slide, I'll get it right eventually. First of all, covalent bonds are between similar identical ions. All right, but you should know this involves sharing of pairs of electrons between atoms. And a basic unit is called a molecule. Oh, it's time for Dr. White to get subtle. And subtle, and know this. What is a chemical bond? A chemical bond between 2 atoms results from the sharing of pairs of electrons. Another way of saying that is a chemical bond, a covalent bond, is a chemical bond with the sharing of pairs of electrons between 2 atoms. And remember, a pair means 2. A pair means 2. I like my special effects. Remember, a pair means 2. So covalent bonds, you're sharing. I always do this like holding hands. Looks like the knuckle coupler of railroad cars. That's one of my hobbies, model railroading. when I was young, like about 5 or 6, my father on Sundays when he had time, take me, not my sisters. They went once, they didn't like it, but I loved it. We go down to the south side of Chicago, this massive railroad yard where they stored and maintained and worked on railroad engines. And when I was a little boy, it was mainly steam engines, these huge behemoths. Ah, awesome. Anyways, I got sidetracked there. Why? No, sharing pairs of electrons, knuckle coupler. So let's talk about Lewis structures for molecules and molecules with polyatomic ions. All right, the first one is hydrogen gas. Hydrogen gas exists as each atom has one, really, this should be valence electron, and it exists as H2. Why? All right, why doesn't it want to go black? Let's try it again. All right, so you're being asked, draw the Lewis structure for hydrogen gas, H2. Well, Lewis structure tells you you're dealing with valence electrons. And if we go to our favorite friendly neighborhood periodic table, we see hydrogen has one valence electron. So each hydrogen has one valence electron. And this hydrogen says to this hydrogen, hey, I have one valence electron, you have one valence electron, and let's share. And they do. And this is a covalent bond. All right, I got a mental freeze. Hold on 1 second. Yep, I was always the first one down in a spelling bee. At least I caught it before one of you did. So what holds the two hydrogens together in hydrogen gas? The sharing of two electrons, one pair. And so hydrogen atoms are held together by a covalent bond. How do you know that? Because they're sharing one pair of electrons too. And that's the structure. Now, remember, only valence electrons are involved in a covalent bond, the outermost electrons. When the atoms come together, the outer electrons interact. And that's why Dr. White loves valence electrons, because those are the ones involved in bonding. Now, let's talk about octets and the octet rule. Now, I'll never ask you this, but this is important background information. Switches off for the slide, click. Atoms share electrons to achieve octet valence electrons for the valence electrons. An example would be if the outermost electrons would be 2s2, 2p6, 8. Turns out the valence electrons are always sp orbitals. Now, let's talk about when we do something. And before I do that, let's do the following. And the question is, draw the Lewis structure for HCl, which is hydrochloric acid. Interesting side note, we'll talk about this later in the semester. Hydrochloric acid, HCl, your stomach has cells that make it. I don't know about you, but I consider that one of the miracles of life that you and I have in our body, in our stomach, cells that make this chemical HCl, hydrochloric acid. I'll teach you later on that's used to break down your food, called digestion. Now, how do you do this? You have to look at the valence electrons. Hydrogen has one valence electron. And I learned that by going to my periodic table and looking at the top where hydrogen is. If I go to the halogens, Cl chlorine, you don't look here, you look up here, has 7 valence electrons. Now, chlorine has 7 valence electrons. Well, hydrogen has 1, chlorine, remember Lewis structure of an element, you write a dot on each side and then you double up. So this has 1, this has 7. The hydrogen says to the chlorine, I have 1 valence electron, you have 1 unpaired valence electron, let's share. And they do. And if you notice, you don't stop writing the valence electrons that are not involved in a covalent chemical bond. And here, between the hydrogen and chlorine, you have 2 electrons being shared. And what is that? A covalent, hopefully I'll spell it right this time. I did. A covalent bond. Now, the electrons that are involved in the covalent bond and the ones that are not involved have names, and you should know these names. The electrons that are being shared in the covalent bond between 2 atoms are called the bonded electrons. Oh. Dr. White's being subtle again. Hint, know this. I'll never ask you on a test, what is a bonded electrons? But I could ask you, circle the bonded electrons in a Lewis structure. Now, the other type that are not involved in the chemical bond, the covalent bond, are called the non-bonding electrons. These are pairs. Remember, bonded and non-bonding are always pairs too, that are involved, that are not involved in the electron sharing. So if I were to ask you, in the structure you wrote in B, circle the bonded electrons, in red, those are the bonded electrons. Or if I were to ask on a question on a test, in your answer for the Lewis structure of HCl, circle the non-bonding electrons. And those are pairs of electrons not involved. And these three circles are the non-bonding electrons. If I look at the clock, oh no, time flies when you're having fun with chemical bonds. We're done for today. Now, let me remind you, tomorrow, lab number 2 is due. You need to include at least one selfie of you with something from your chem kit, like the Alka-Seltzer tablets, like your thermometer in a cup, and you with your safety goggles on. Remember, when you're doing the lab, wear safety goggles, and you can include your selfie either in the PDF file of your lab report or as a second file that you upload. And remember, these are easy 10 points if you do it right. And if you have any problems with the labs, always feel free to contact me. Also, don't forget, tomorrow I'll do my world famous review for the next test, test number 1. And I have my office hour tomorrow night. With that, we're done for today. Gang gesund. Goodbye. Bye now. Gang gesund.